this is problem 126 of Neetcode 150 and of traits. So we're going to be given an integer array, hands, okay? And we're going to be also given an integer called group size. And group size is the length of a subgroup we are going to have to make with the numbers inside hand. So for example, here we have an array and that contains 8 numbers, and we're being told that we want us to create group of size 4. So we have a class of 8 students, and the teacher says make groups of 4 people. Okay, so we're gonna expect to have 2 groups of 4 people in our class of 8 students. I think this is pretty straightforward to understand. So if it was only this, that would be quite easy. But the problem asks us to basically have 2 groups where each numbers is monotonically incremented by 1. Monotonically means like a constant increase of 1. So for example, the first group could be composed of 1, but if it starts with 1, it means that the other values are 2, 3, and 4 respectively, because it has to increase by 1. Right, so now the first, the example here is outputting true because we can create a first group of 4 students with the students 1, 2, 3, and 4. And we can also use students 2, 3, 4, and 5. Where in the example 2, we have basically a class of 8 students again, and we have to make groups of 4 people. So the number of people won't be a problem. Notice that though that if we had a class of 9 people and we have to create a group of size 4, that will be a problem. But in our case, we don't have a problem for the number of people per groups. But in terms of having monotonically increasing groups, well, here comes the problem, because we can create a first group composed of 1, 2, 3, and 4 as this example, but then we will have a value 3, 5, 6, which doesn't work already, and then 7, because we basically pass from 3 to 5, which is an increase of 2, and this is not something we can do. All right, so with that being said, let's go on a whiteboard and see how we can solve this. So let's say our hands is composed of 9 students, and I also created a min heap on the right, and I've also drawn in yellow the number of occurrence of each of these numbers inside our hands. We are being told here, well, I'm telling you in our example, that we are going to have to create a group of 3 students. So from a first perspective, we know that this is going to output through because we can create 3 subgroups that increase monotonically. So that will work just fine. Okay, so this is good. But how do we actually solve that? So the first thing that we want to do is I'm going to create a min heap, and every time I will pop the first value, and I will decrement the number of times that I can use this value, because right now I can use only one time. So from my min heap, I have a 1 and I can use it one time, but now I'm gonna pop it, so I'll be at 0. And whenever a value is at 0, I'm gonna also basically remove this value from the min heap. Okay, so now I have a 1. Okay, this is good. But now, if I want to complete my group, and I need a group of 3 people, I will need 2 more people. So I will need a 2 and I will need a 3 respectively. So I want to know if I have these values inside my hash map or my min heap. And I want to know if I can actually use them if they're not set to 0. If they are, I will basically use them. So I will put their frequency to 0. So I can use them 0 time. If I was only able to use them once. But for example, here in this case, my 3 as actually two occurrences. So I can use this one more time. So I'm gonna keep that inside my min heap. So now this is good. I have a first group of 3 students that works. Now I will go in another round and I will basically pop the first value of my min heap, which at this point is a 3. So let's do this. And what I will do is that I will see if I have a 4 and a 5. It appears that I do have a 4 and a 5 here. So their frequency will be set to 0. And also I use my 3 as the first value inside this second subgroup. So its frequency will be set to 0. So I'm going to scratch these values. By scratching, I mean removing them from the min heap. And also I did an error here because there is no 9 in our sequence. It just came from the previous example I made before this video. Okay, so this is good. So now we are going to go in another round since we completed a second group. We're going to pop the top value of this min heap as it's going to tell us what is the minimum value that we have basically to build another group. So we're going to start with a 6. And now we're going to go see if there's a 7 and if there's an 8. And notice that this is the part where it might fail, and this is where we might going to return false. Because if we can't have our 7 and our 8, or if we just can't have our 6 at all, or if we have like another number like 9, and then that will make us 10 numbers to create group of 3, which will not work. So these are all cases where it will actually fail. So I'm gonna pop my 6. I'll use it, so I'll decrease its frequency by 1. Then I'll see that I have a 7 that I can use. So I'm gonna decrease its frequency. And same for the 8, and I'm gonna pop them all. Okay, so that's pretty good. And from there, you can see that my min heap is actually well, it is done, right? So from this position, I can return a true if I popped every single values and never encountered any edge cases. So let's go ahead and solve this problem. So the first thing that I want to do is that I want to say to return false if we have basically something that is impossible. For example, create a group of 7 people with 3 students, or for example, create a group of 5 people with 7 students. That won't work either. So basically, that falls into if the length of hands divided by the group size. If this gives a reminder, if it is not 0, we're eventually going to have decimal numbers, but we can't have like a decimal person, so that will just not work. So we're going to return false. All right, now I'm going to create my hash map, which will basically count how many times each value can be used. In my example, it was basically embedded inside the min heap. You can probably do this as well, but I will just create my own hash map. So the hash map is now created, and I can go for num in hand. And what I want to do is that inside my hash map, at this num, I will set this equal to 1 plus any value if there is any. So it's going to be hash map, and I want to get the num, or I want to set this default value to be 0. So now I have my hash map of frequency. I'm going to create my min heap. So min heap is going to be basically, it's going to be the list of this hash map. And I don't only want to take a list of this, I want to take the list of the keys only, right? Because the keys are the actual numbers that appears in hand. And then I'm gonna eepify this thing. So eepq.eepify, and this is probably gonna be the most well, the less efficient operation in our solution. Oh, All right, so good. Um, Now we can have a while loop while um, there is a there is a min heap, and while there is a min heap, I want to start a new sequence at the value that will pop from the hash map. So from the min heap. So this is going to be the first element, so at the index 0. That's going to be the smallest value we can use so far. Okay, and I will also check if this is in the hash map. So if start in hash map, reason is that once we once we're done with a value, once we can no longer use it, I will basically remove this from the hash map. So um, so that's how I will know that this value is has been used completely. So if start is in the hash map, it means that we can still use it. So I will go basically see the next two numbers that follows this number. So I will say for x in the range starting at start up to start plus what is it called? It's called group size. Okay, so now we're gonna go see basically if let's say that our group size is 3, we're gonna go see its value plus its two nearest neighbors. So if we start with 4, we're gonna go see 5 and 6. And basically what we want to do with these numbers, we want to see if they actually exist, so if they are in the hash map. So with that being said, we're gonna say if hash map that get, and you want to get this x value. Okay, and I'm just gonna set this equal to 0 in case that there's something wrong happening with x. So if this is smaller or equal to 0, which should not happen, but if this is happening, so if this is actually smaller or equal to 0, um, we're going to return false because we cannot use the next value that we will need to complete our current sequence. Okay, and after this, we are going to consider that we use this value. So what we will do is that in the hash map, at the position of that particular number, we're going to decrement its count by 1. And then we want to see if by decrementing its count by 1, we made its count equal to 0. So if the hash map at the index of x is now equal to 0, well, we know that this was the last time we were allowed to use this particular number. So what I will do is that I will delete this from the hash map at the index x. And I will also remove this value from the min heap. So I will say heap q dot heap pop, and I want to pop from the min heap. And notice too that at this moment, the value that we're deleting from the hash map is like the second smallest value after the value that is the start, right? Well, the start itself is gonna pass in this x, right? Because for x in the range of starting from start, so the very first x we're gonna get is this start itself. So then we're gonna go see the smallest value, then the second smallest value, then the third smallest value, and each time, if by decreasing their count by 1, so by using them, we are making them having a count of 0, well, it means that we can no longer use them. So we're just gonna delete them from the hash map because we can no longer use them. And I will also pop the top value of the min heap, because that top value, if we used it, it means that that top value is basically that x value that we just, the same that we removed from the hash map. Great. So at the end, we can return true. Because if we never return false here, it means that everything went perfectly. So we found all our sequences and it worked just fine. So we can test this out. We have a time limit. Okay. Why is it so? So it seems like we got caught in a time limit error. So what I see is that we got caught in the edge case where we just blindly pop the first the top element of the mini heap, thinking that it will be the same as the one that we deleted from the hash map. Because let's say that we add a one in our sequence, we're gonna expect to have the value 2, right? Because it has to increase by 1. But what if in our hands we only have 1, 3, 4, 5, 6? Well, inside our mini heap, if we just pop the top value, we'll pop 3, which will cause an error. So what I will do is I will just add a safety check. So I will ask if x is equal to the top value of the min heap, so in min heap index 0. If this is the case, I will want you to pop this value, right? So this is the minimal fix we need to do. So now it worked. There's also another way to solve this problem. I mean, it's definitely not a big deal, but you can basically use the number of rounds that is needed to form the number of groups that you want. So for example, if you need to create groups of 3 people with 9 students, you know you're gonna have um, three um, three groups, right? So I will just create something called round, and it's basically gonna be the length of hand divided by the group size, and I'm placing that right after this initial check. And instead of having a while loop while there's a mini heap, I will just say for in range of the round. Okay. And basically, instead of returning true, I will return um, if not hash map. So, or if not min heap, both will work because at the end they should technically both be empty. So this is also something that works, but it's not gonna be more efficient. This is quite efficient. I think this is the time complexity they're asking us to have, like big of n log n. And basically, this time complexity, big of n log n, is the heapify here. So it's the longest operation here. So heapify, it's big of n log n in time complexity. Yeah, but in terms of space complexity, we're creating a hash map of the length of the hands, right? So what we're gonna have as a memory complexity is gonna be big of n. With that being said, I hope you enjoyed the video. I hope you learned, and I also hope to see you in the next one.